Hi, welcome to Parametric House. In this Grasshopper tutorial, I want to show you how you can convert two sections into a parametric tower. And as you can see here, if I set these to the two top curves, I can change the shape of the tower easily, which I'm going to explain the algorithm. Then you can diagonalize the mesh using the Kangaroo plugin, which I'm going to explain, and get the final results. Okay, let me turn off everything, and you can download this example file from our website. Okay, let's start with two curves. We just have two curves as an input. We loft them together easily. That is really easy to do. In the loft options, what I have used here is align the sections if you want to have them in the same direction. So for example, if I type dir here, you can see that the direction or the seam at least is not in the same position. So if the seam was here, the loft was okay, and if I don't hit on this loft option aligned section, you can see that it's not going to give you a good result. So that is also important. After aligning the sections, okay, because we loft these two curves together, maybe it's a polyline here. As you can see here, this is a polyline, but it's a NURBS curve up there. Obviously, most of the times we're going to get a poly surface. So if I bake that in Rhino, you can see that this is a poly surface. If I explode it, we will have multiple parts. So this is going to actually give you a poly surface. To go forward with Kangaroo, what I have done here is I have exploded it into the faces, deconstruct brep. As you can see here, this is going to give you separate faces. Then I have used the mesh surface, which you can find in the mesh utility mesh surface here, to convert it into a mesh. The good thing about this is that we can give the same number of divisions for all of those poly surfaces. So now you can see that, for example, for the U count, if I change that, in the height, it's going to all be the same. So that is the most important part. For this one, you can give different numbers for the poly surfaces. For example, what we can do here is to go to the surface analyzers and get this dimensions. And for the V, because the poly surfaces are going to be different, what we can do here is to, based on these numbers, give the division. So I can say sort them. So it's going to be from the smallest to biggest. Then I can pick up the first one with a list item, which is going to be the smallest. And let's assume that the smallest number, or the smallest, actually, what was it? It's a U. It was the V. So assume that this is the smallest we have in the poly surfaces, and the length is 80. Okay. Assume that we want to say that the smallest one has two divisions. So it's going to have two divisions. What we have to do is to divide this number into two, and it's going to give us a 40, and then this division, this number is going to be divided for all of those poly surfaces. So what you can do here is to say the smallest number can be divided into 1, which is going to give you only one edge for the mesh, or it can go to up to 12, for example. So then I'm going to say from the math, divide all of the V divisions with this unit I have. So as you can see here, it's going to give us some divisions based on a resolution kind of a V, and then I can give it to a V. Here you can see that the smallest one here, which was this one, is divided into one edge, and others are going to be based on their length, maybe even divided into two, as you can see here. And then we can increase this resolution. It's going to give us somehow a cleaner division if you want to play around with this. So I'm going to also save this for those who want to work around with the V. After we have made the mesh surface, we can simply join them together. And then we can weld it. This is really important because, as you can see here, when I join the meshes, it's like 480 vertices, but after we weld it, it's going to be 396. This is going to give you a better mesh. I always try to do that. So if I bake that, I check it out. I don't see thickened edges. That's going to indicate that it's not really joined together. But when you see a really clean mesh, that means it's a singular mesh. Okay, so that is also important. Okay, after having the mesh, I'm going to use the Kangaroo plugin. For the Kangaroo plugin, you can see that I have a zombie solver. This zombie solver is going to show you the final results without going into like an animation output. So the first goal I always use for a mesh is I give it to a show component and give it to the goal, and I always flatten it so I have all of the outputs at once. Then I usually use a goals mesh edge length to relax the mesh, and for the length factor 0, it's going to give you like a really smooth mesh. So I'm going to give that 0. You can increase that up to 1 if you don't want the length to change. Anyway, that is going to be the second goal. The third goal is to go to the mesh and use this naked vertices. As you can see here, it's going to give you a series of points. For the naked points, which I need here, is going to be the top and part points of the mesh. And we can use the goals point anchor and say these points are the anchors of the mesh. So when we relax it, these points are not going to move. And that's it. We're going to give that to the zombie solver. After giving it to the zombie solver, you can see that we have this clean mesh. Because we have given also, after giving the mesh, I have given also the edge length. The output is going to be first from the mesh, because this is for the show, and the other are going to be from the edge length. So we're going to get rid of those and pick up this one with a list item. List item index 0 is going to be the mesh. After having that, we're going to diagonalize the mesh. As you can see here, if I turn this on and turn this off. So this diagonalize component is a really great tool to make the mesh faces into a diagonal, and it's really easy. So it's based on the division you have given here in the UV. Okay, after having that, I just made a custom preview so you can see this mesh. And let me also turn on the mesh edges so you can see it. So after we have the diagonalized mesh, we can also get the somehow like a floor thing just for visualization. After that, we can use this mesh warp weft component, which is really great. And as you can see here, if I connect a curve to the A output, it's going to give you the warps, and B is going to be the wefts. And it's really useful in many projects when you want to dispatch them into two groups. So now I just use those curves, join them together, and give them into a surface output here like this. Remember that when you increase the length factor to something more than 0, sometimes it's not going to give you an output, especially for complicated forms. But for 0, it's going to give you flat surfaces, because it has to be a flat surface to increase, convert that into a surface. If I bake that, and as you can see here, it's going to bake those surfaces easily in Rhino. So that is all the algorithm. You can download it from our website and just check it out. Try to give different curves to the bottom and the top of the tower, and you can get really interesting results. I hope this tutorial was useful. Remember to like this video, share it with your friends, and subscribe to our channel so you get notified about our new videos. Thanks for watching. See you next time. Bye.